Hello everyone, XCT here. So this is a video on Ifrit, which is a new red team lab on Vulnlab that was just released last week. And if you go to machines here on the Vulnlab website, on the bottom you can see the logo. And Ifrit is basically an easy lab which has a kind of easy attack path, but what makes it a bit harder in the end is that there's a SOC which is detecting like a lot of things that you are trying to do probably. So if you just want to do a pen test, just get through it, like don't care about detections, that's fine, then it's more on the easy side. If you care about not getting detected at all and being stealthy, then I would say it's more on the hard side. What I'm going to do in this video series is basically try to not get detected, so you have a bit of an idea what you can do in red teams and not only like on pen tests where it doesn't matter. Not all of the things that are shown are going to work in all environments. Obviously, there's a SOC here, a seam here with detection rules set up that are pretty default, so they are not like crazy custom rules. There are some custom rules for like honeypots and stuff, and I'm going to show them. But in general, it's a fairly like default setup that you would have if you freshly install your seam and activate all the vendor rules. So in terms of red teaming difficulty, it's more on the easy side, but it's still a pretty big challenge to do this without actually triggering anything. On the Vulnlab wiki here, there's a page for this red team lab, and there's a short lab intro here, which is basically just telling us that the objective is that you are supposed to get DA in one of the domains, and that it's an assumed breach scenario. So you actually get a user that the company set up, and you can use that user to log into a starting point. In this case, there's a remote desktop environment here, which is sort of like a kiosk thingy. We will see that in a bit. You can just log in there and then start the lab from a machine inside the target network. Then there's some technical things and some hints, but we're not going to look at that yet. So the goal here is for, on the one hand, basically to serve as a walkthrough for the lab, but on the other hand also, if you've never done a pen test or red team engagement, you can basically watch me do this and explain a few things on the way, and maybe you will learn some things you can use on your own engagements. All right, so let's get started. All right, so this is the entry point of the lab. If you just go to the URL that's given in the wiki and log in with the credentials, you get this kind of view here that allows you to start Firefox or WordPad. Just going to click WordPad here. This gives an RDP file, and if we open it, in my case here with Reminer, you can see that this actually allows us to connect via RDP and logs us into the app. You will see in a second that the log is not very efficient, but this is what it's supposed to do. Okay, so you might think like, what if we just RDP directly to the machine? We have credentials, right? You can do that, but you will instantly be logged out because the way this is set up, you are supposed to use this app. And there isn't really another way to log in without starting in the app. All right, so we kind of want to escape that, right? We want a real desktop, Explorer, all of these nice things. So what we can do is basically just go to the Save As dialog, and you can see that already the restrictions are not very, very strict, right? We can go to the C drive. There's also a network share here. So yeah, it's not very efficient. And also if you just type here, we can run commands. I'm just going to start the task manager. And at this point, we can already close WordPad. We won't have anything here. But the reason for that is just that Explorer is not running. So why not just start it, right? And now we have a normal Explorer and can work normally on the machine. What else do you want to do? Well, you could think like, oh, let's start a PowerShell or something like that. But that would actually maybe get detected. So we want to go with some soft enumeration first that doesn't really stray too much from the behavior a normal user would do anyway. So let's just open another Explorer here. Then we can already see we have a home folder here that is hosted on DC03 in this homes directory. So one thing we could check is, well, are there any like other shares on DC03, right? And at least from this view, we see there is this home share, all right? But we can't access it. We can only access our own folder, okay? There's this folder, also often like a very nice place to find stuff, but in this case, there's really not much here, except for a few GPOs. And there's this transfer folder, Apparently someone placed like an important file here. But it's actually not related to lab. It's just some other pen tester actually trying to exploit this. Yeah, and other than that, we don't really see much here, but there could be, right? So it's worth checking. Okay, let's look a bit around on the local folder here to see what we're dealing with. Also, Task Manager, we can just see like if there are other users logged in, right? There are a couple users here. Details shows us processes of all users, so maybe something interesting here. Could also check that. Services. I mean, we got quite a few like infos here without running any commands, right? But for now, I want to like look around a bit the file system. There's this install thingy. Okay, it's empty. There's inetpub, which means there's a web server running. I mean, we knew that, right? Because this is the web application that's running there. We can go into www root here, but it's empty. So the actual RDS website is hosted somewhere else. Also, it's always like interesting. Can you actually write here? Like, but we can't. But in case you could basically escalate privileges, right? If you can write to the web root. So always interesting to check. Also, let's just show hidden things here. Makes it a bit easier. Have a look into program data. There's an Ifrit folder. Okay, but it's empty. Doesn't really help. Let's see users. Interesting, of course. You can see there are definitely more users here than we actually saw when we looked at the users list here. And well, the reason is that not all of these users are currently logged in, so they don't show here, but their profiles are still here because they have been logged in at some point. And you can see that includes the domain admin of the Ifrit domain as well. So this is kind of an interesting system because the DA was logged in. We don't know what these other users are yet, but they could also have like interesting permissions or anything like that. So you might want to go for a privask on this machine, but of course a privask is also not always possible. So even if you like think, oh man, I really need one, doesn't really mean that that's the path forward. Okay, so we saw a couple users here. Let's see what kind of applications are installed. That's also always important. We can see Elastic here, so might give us a hint at the AV. There's Sysmon, so that's probably gathering some logs, right? There's Amazon, so probably an EC2 instance, which is also not too uninteresting in real life scenarios, right? Because maybe this has like instance metadata or something like that, but we're not going to follow up on this here. There's program files, nothing too interesting here except there's Firefox, okay? Yeah, and that's about it, what you can like directly see here from interesting files and all of that. Also, since we have the UI, we can all without issuing any PowerShell commands or so, just look around, see if we can find some details about the AV. So it says engine unavailable. Let's see what that actually means. Is it turned off? Well, no, it's actually turned on, but GPO locked. So even if we were an admin, we couldn't easily turn that off. Tamper protection is turned off, okay. Exclusions are also interesting, but if we click that button, it will essentially ask us for credentials. So just going to show that here. Yeah, we can't do that. So viewing exclusions is not allowed. But there might be some, right? We just don't know which exclusions might exist. Okay, so how about getting some basic AD info without like running any tooling or something like that, right? Let's just go to any folder here. Go to properties, advanced, security and then advanced. And then just, I don't know, go here. What I basically want is this dialog where it allows you to search the Active Directory, and you can get that via different ways. It's just one way to actually get there. And if you go to advanced here, we can actually search AD with this. And this is the basically UI component that's doing that like normally. So we are not really doing any unusual behavior, right? So for now, I want computers, groups, and users. And if you go to locations, we can actually filter that down. And before even like going deeper into that, you can already see that there are multiple domains. There's EU Ifrit VL, there's Ifrit VL, and there's IT Ifrit VL. And we can all see that without like running any command or tool. We can also see all of the UUs, their clients here, their computers, consultants, internal IT. Let's see what else. RAS, system users, and VDI, which is probably virtual desktop environment. Yes, and we can just search all of that. So let's see, for example, what are all consultants. We just define now, and we get a nice list of all users that are in the consultants group, right? So this is already a way to find users without like doing any crazy tooling, right? Computers as well, we can just like query all of them, but it's probably not really all of them, just in this specific organizational unit, right? So if we just go here, we should get all of them from the domain. Well, now we also got the users, so we can say, well, just give me the computers. And then we get a list of computers here, which is quite a few. So it's not just like 3 machines, right? There's something going on here. And we can also see that one is disabled here, which is the VDI01, but the others are like normal computers that probably exist in some kind of way. Also, we could go for descriptions here. So let's do that again. And we can also get the descriptions, which is already kind of useful, right? We get some things here. Okay, that's like the gateway server. Okay, we knew that. These are development clients. Okay. How about users with descriptions? That's kind of a thing that can happen, right? So let's go here. And you see most of them don't really have the descriptions, but some of them do. And you can actually see that 2 of them here have initial password kind of thing set in description. I'm not really going to go for these ones yet. The reason for that is if you're like used to labs and doing it all the time, you might just like try to do something with them. But we don't even know the permissions of these users yet. And also this looks a bit like bait, right? So it could be honeypot users, and the SOC would like instantly detect you the moment you use them, if that were the case. So better to be a bit careful, just note the credentials down for later and then maybe decide what to do with them and not like directly jump at the first chance you see. Okay, so we learned a lot of stuff here already, but in the end we still want basically a connection into the internal network to like do lateral movement, like do different things, right? So in this kind of run I do through the lab, I'm not going to use a C2 framework. I want to cover a technique that mostly just relies on signed binaries that are trusted and SOX proxying. So we are not going to use a C2, we are not going to use something like Metasploit or Sliver or anything like that. We are just going to try to solve everything by going through a SOX proxy and doing things on the UI on the initial machine. We don't really want to do anything else here. How can we actually establish a SOX proxy here without like running any tooling or anything like that? For this, we actually have to start a CMD now, but actually CMD is not so bad, so it's actually not getting detected. In contrast to if you would start PowerShell, there's a really good chance, and in this case, in this lab, you will get detected the moment you start PowerShell because the normal users are not using it. CMD, they kind of probably don't use a lot as well, but there are obviously also things that normally run in a CMD. It could be a startup script or other stuff on the machine, so CMD isn't that unusual, while PowerShell is. So CMD kind of fair game. Of course, it also depends what you do in a CMD, but just starting it is fair game in contrast to PowerShell, where just starting it might be not the best idea. So how am I going to establish a SOX connection here? Well, in general, there are different tools you can use, right? You can use something like Chisel, or you can use the SOX proxy that your C2 framework is basically providing you with. You could do stuff like Cloudflare tunnels or Azure Dev tunnels or something like that. In this case, the lab itself has no outbound internet connection, so these are kind of dead. But what we can do is we can use SSH. And if you just type SSH, you can see it's installed. And that's actually the default on Windows servers that the SSH client at least is installed. So what I'm going to do is essentially this. Just run it and then I'm going to explain. So what did I do? I created a SSH connection to my own machine which of course in a real scenario could also be on the internet. And with -r, I opened a SOX proxy on the target machine, so my own machine here, which I can just use to tunnel traffic into the target network. And with the -p, I'm just modifying the port because my SSH server is not running on port 22, so I use that. And I use -n to not like have an interactive shell. And this is basically all that you need if outbound SSH is allowed to access the internal network. It doesn't mean that you can just like run any command and it will be safe, because obviously there's figures that can look at what the process does, what kind of traffic is going through the network. But in terms of pure connectivity into the environment, this is already pretty good. And in this case, also not detected by the default rules. So kind of an effective way to do it. All right, so now we have a SOX connection into the target network. Okay, so now before actually using the SOX connection, I kind of want to know what the IP of the domain controller is. And I don't want to NS lookup or ping or ARP or anything like that, because it might be detected. So we can go into the control panel here and just do it in the UI and we'll be fine. Just like a more natural way to do it, I guess. Let's see, I think it's here. Yes. Details. And we can see the DNS server is 4114. So this is very likely also the domain controller. Let's actually verify that by using proxy chains nmap, and then we do LDAP and SMB. And then the IP we just saw. And yeah, we can see both ports are open. So this is very likely the domain controller, right? Also earlier we saw this password in description, just going to write it here. I think it was this one. Okay, so we can actually reach in a network. We know where the DC is, so things are kind of in a good position, I would say. One thing I would really avoid here is scanning port 88, because then you are kind of simulating Kerberos traffic, and Kerberos traffic coming from an unusual process is actually one of the detection rules. So even the default ones. So try to not talk to Kerberos while going through this SSH proxy connection. It will be detected. What you kind of want now is something like BloodHound, right? But if I would just run the Python BloodHound thing, it's very likely to be detected. The same is true for the crackmap.exec or netexec variant of it. So we have to kind of find another way to do this. So there's this website called live.sysinternals.com from Microsoft, where you can get all the sysinternals tools. And one of them is AD Explorer. And this is kind of like a UI program that allows you to explore the Active Directory a bit, and also to let you take a snapshot that you can store offline and then work with it. So it's kind of a good way to get an AD dump that might not be detected. It could be, right? I also saw in environments that people detect this because it does not many queries, but a few very large ones, so it is detectable. In this environment, though, it's safe. So I'm going to show it. So first of all, we have to bring it into the environment, right? We could grab it via a browser from our machine. That would be fine. I'm going to use SMB client here. This is the user. That's my assumed reach user. And I should be able to connect there via the proxy. And shares, yeah, there was this transfer share, right? We saw that before. And also, now that we are listing shares here, let me copy that here. You can see something interesting we didn't see before. So there's this home backup share here. And we didn't see it in the UI because there's a $sign at the end, and these are actually hidden in the UI. So you want to make sure to check this with a tool that can actually display them, so you don't miss any shares. And also, of course, there are like scripts that check it and so on. In this case, this is pretty interesting, right? Let's actually also go here, just see what's in there. And well, it's called home backup, so it's probably the backup of the home directories, and there's a vhdx file here, so this is likely a backup containing some data from the home directories. I'm not going to get it now because it takes a bit of time to download, but just in general, like, remember this file. This is also essential for the path forward, and even if you didn't know that, obviously you want to look at the contents, right? Okay, but what I really wanted to do here is use the transfer share. this one, and then just put our tool here, which is adexplorer.exe, and this way from here I can just go there and actually copy it to this machine here. So DC03 transfer, let's cut this. For now, let's copy it to just our user folder, I guess. Okay, so now that we have the binary here, well, you could think you could just run it from here, right? There's two problems with that. One of them is being, if we run it from our home folder, we are executing a binary from a shared folder or from a share, essentially, which is also something seam rules can detect on, and in this case, it would alert. So we can't run this from here, and we have to know that in advance, otherwise at this point you're detected, right? So what can we do instead? Well, you could think like, okay, let's just, I don't know, copy that to the local downloads folder and run it from here. Kind of okay, but it wouldn't work in this case because there's application control in place. And how do I know that? Well, one thing you can do is you can go into rec edit and then check the registry keys. So you can see the full path of the key here. And essentially this is where AppLocker stores its values. So let's see. We can see enforcement mode actually set to 1. So AppX is enabled. DLL is not enabled. But for exe, MSI, and script, it's enabled. So except DLLs, everything in AppLocker is enabled. And we can also see the rules here. Let's see if we can actually read them for the exe files here. And it's already a bit suspicious that it's only 3 rules. So this kind of means someone created the default rules and left it at that. So let's see what this rule could mean. There's like a wildcard here. It's a bit hard to see, but essentially it's, I believe, denying everything that's not allowed, but it's also, like I said, a bit hard to see here. Oh no, actually we can see it here. It's essentially allowing admins to run everything, right? Yes. So admins are allowed to run anything. We're not an admin, so we can't do much about that. Let's see. This rule is doing, well, it's allowing the Windows directory. This is already kind of interesting. And then we have this, which allows the program files directory. So we kind of enumerated AppLocker rules without just mindlessly running it and running into the block. I think on this lab there's no alert on like triggering AppLocker if you run into it, but of course you could also detect on that. Like if someone accidentally does it, like just detect and do whatever you do after you detect someone, right? Okay, so download's also a bad idea. Yeah, but what about, let's move it back for now. What about if we move this to the Windows directory, right? AppLocker has a few default exceptions like Windows tasks, Windows tracing, Windows temp, but also other ones. Let's just go with one of them and copy this to, let's do Windows temp like this. Yeah, we have to put C here because we're not on C. We copy it there because this is an AppLocker exclusion path, and if we now actually run that here, okay, so now we can connect where we want to. Let's do DC03, give it the domain, the user is this one, and we have to give it the password, and then we can connect here. All right. So now we already get quite some information here. If you just click through this, right, you can see again the different OUs, and now you have like a bit more info here than you could see in the search gadget earlier, right? It's a lot more information. Also, you get the descriptions and everything, the home directories. So this is already a good way to explore the Active Directory. And when you click around, I believe these are live queries, but you can also get an offline copy of this whole thing. So if you go here and then do create snapshot, we can actually have it create a snapshot for us. So let's save that also in the temp folder just as snapshot.dat. Or maybe let's do program data so we can see it, because temp you can't list. This makes it a bit easier. And then you can throttle this here a bit. So if you don't want to make a lot of queries fast, I mean, it's not really doing a lot of queries anyway, but you can slow this down here a bit. In this case, the idea is not that big, so it doesn't really matter. I just slowed it down like a bit, but yeah, it's not really too important in this case. All right, now in program data, we should have the result. It's here right now. We can copy this again onto the share on the DC. Makes it easy for us. Just put it here. Then we do get, well, just an ls now to see it's here, right? Then get snapshot that, and now we have it offline. All right. I'm going to delete it again, not that someone sees it, right? And also just to show you, you can also access the share here by putting the $mark and get the file here, right? So you don't have to use SMB client for that. The only thing it doesn't do here is actually list it because of the $. So now ideally we want to convert the snapshot into a format that's ingestible by BloodHound, so we can use it in the UI from BloodHound, right? So there's a project here called AD Explorer Snapshot, and well, it's exactly doing that, right? Let's create a virtual environment here. Install this thing in the virtual environment. And then let's see. Let's run this. It needs essentially just a snapshot file, and then you can choose between BloodHound and these objects. So let's give it the file snapshot.dat. And you can see there's an error here, and that's a bit annoying. But if you go to Chrome and look in the issues from this project, you can see that some guy here fixed it by changing this preprocessed cached to just preprocess. So let's do that as well. It's actually in here, and then it's this init file, and then I think it's, let's see, output BloodHound. Yeah, so let's just comment that. I think it's just like that, and if you run it again, should be fine. Yeah. So you can see the JSON files now here that we can import into BloodHound. So let's actually do that. All right, and now we should be able to see our user, for example, here. Yes. And we can see group memberships and everything that we usually see in BloodHound, right? So this works, and it's also a pretty good way to do it. In this case, the theme doesn't detect it because there's no particular rule to look for these big queries that the program is doing. Good socks, however, can detect it. So it's not a fail-safe method to do it. Let's see. It looks like we got a lot of info in here. But one thing we don't really have is good ACL data. So there's some stuff missing here. It's not really that complete. You can work with it. It's nice to have like an idea, but there's actually a better way to do it, which I'm going to show now. So let's first deactivate this. Right. And what you can also do is LDAP search. So just the normal Linux LDAP search thing can also like get all of the information from AD, including all the ACLs. So this is what we're going to do with this beautiful query. These three L's here are basically just telling it to be like have like less verbose debug output and stuff like that. Then you have to give it user the password, and also there are a couple of options here which I don't want to go into a lot of detail. This is a thing that fixes some error. It's not too important for this video. And essentially, this is the query which is telling us to grab everything, right? And if we run this, we essentially get all the output from LDAP And if we scroll up a bit here, you can see it's like all the like home directory and drive mapping, all of that, right? But also this large base64 blob. And this is the security descriptor that has like all the ACLs and relations to other objects. And we have that for every object here. So this is basically all the information a normal BloodHound ingester would probably also get. All right, but now we have this txt file. And yeah, it's not really ingestible by BloodHound, so we kind of have to work around that. So luckily, there's a project called BloodHound, and this kind of is what we exactly need in this situation. This is an result parser basically from LDAP queries. It's meant for a buff that can be used in a Cobra Strike and other C2s, but it also kind of works with the output from LDAP search itself, but not quite, as you will see. There's still like one caveat that has to be solved in order for this to work. So first of all, let's clone it. Then again, we are going to do a virtual environment. Just copy this here to save some time. Right, and then we do pip install again. Let's leave this. And then we can do BloodHound-I and ingest this objects file. This is what we expect, right? But it kind of tells us that it couldn't parse anything. And this is essentially a formatting error that we have to fix. And there's a really nice script here by Cozy from the Vulnlab Discord. And if we go there, it's a parser for this particular BloodHound version, which is also the latest one. He also has this LDAP search query here, and essentially all that we need to do is grab this whole thing here. Let's just wget it, and then run LDAP search parser on our objects.txt, and maybe like call the output like this. And then if we do BloodHound again on this converted output, you see that it actually works, and now it parses all the users, groups, domains, and so on, right? So this is way better than before. And if you just like want to compare the format, it's just different, right? It has these dashes here, a bit of different, like just formatting, right? But it's the same information as in the objects file. All right, so this is even better. Now we got these new JSON files here. Let's just import them. And now we should also have all the ACLs. Before you couldn't really see that they are missing, but since I know them and I know of the issue, well, I just know that we had to fix it. If we now go to VDIO2, which is the machine we're on, right? It's the assumed breach machine. We can see something interesting. It says high value targets are reachable. So how can that actually be? I mean, it's the very first machine, right? It would be very unusual. Well, there's a write account restrictions relationship here between VDIO2 and the domain controller of the domain. So if you would actually get system privilege on this machine, we could probably exploit that to pwn the whole domain. In this case, this will be hard to actually escalate privileges on the machine, but it's interesting to like keep in mind that this is possible. And also a good like thing to see that the ACL is actually working. Okay. So what about our own user? Maybe something new popped up here, right? No, right? There's not really anything in outbound object control. We see we are in a group called remote access. Well, that's probably because we can, well, the reason why we can log onto the VDI machine. Other than that, don't really see much here. We saw these dev computers. We can also check for them here, but nothing really sticks out. Maybe you couldn't look for like inbound edges, but these are all privileged groups. There's not really anything going on here from a pure AD perspective that would get us going at this point. Yeah, as for the next step, you would probably want to go for the backup file we saw earlier, right? And continue on that file. So what you would do for these VHDX files, essentially copy them onto the Windows system, mount them, and then look at the contents, right? Okay, so that's essentially it for this particular video. I just wanted to show you how to get started in the lab, how you can go with proxying, give you some idea how to enumerate the environment when you just first hit it, what you can do in the first 1 or 2 hours when getting into the environment. And yep, the rest is essentially up to you for now until the next video gets released. I'm just going to continue on the path and then essentially just make sure that we don't get detected, or when we get detected, point out why that is and what we can do about it. So thank you very much for watching and see you next time.